Today we're going to be looking at measuring angles, okay, how to find and compare the measures of angles. Much of what we're going to look at on this first page in your interactive notebook should be review. And then we'll also be looking at the angle addition postulate, which has similarities to that segment addition postulate that we worked with earlier this week. So if you open up your angles page in your interactive notebook, you can write in the definition of an angle. So by definition, an angle is formed by two rays with the same endpoint. Two rays with the same endpoint are going to form that angle. So underneath the word angle, we are going to identify those points in. So we said again that it's formed by two rays with the same endpoint. That same endpoint that they share is what we call the vertex. So in the example that they show us, angle ABC, the vertex is that point B. The two sides of the angles are those two rays. Remember, when we name rays, you have to start with the end point, and your arrow goes to the right. But the first letter that you write always has to be the end point. So then the other side is ray BC. When we name an angle, we have several different ways that we can name it depending upon the information that is given to us. One way we can name an angle is we can use just the vertex. So we use a symbol that looks like an angle, and we can use the vertex. We can do that if it's the only angle in the picture that is using that vertex. So we can do that because we only have one angle in the picture that has the vertex of B. Sometimes, not always, but sometimes they will number inside of the angle. If they have a number inside the angle, you could also name it using that number. So I could call this angle 1. The other options are to use 3 letters. When you use the 3 letters, it's just like if you are tracing the angle, which means that that vertex is going to be in the middle. So I could trace it and name it angle ABC. Or I could go the other direction and name it angle CBA. So that vertex again has to be in the center. And then although we haven't reviewed it again, we should know if we classify it based on its size, acute, right, obtuse, or straight, what kind of an angle do I have here?
Acute.
It would be an acute angle. When I look at this next piece, it's in the upper right-hand corner of the page that you have in your interactive notebook. So here we've got several different angles in this picture. So number one says blank is in the interior of blank. So when we look at our diagram, I see this point U that's just kind of hanging out here in the middle, okay? So this point U is what we call, or say, is in the interior of an angle. And I'm going to name angle 3. So we can have points that are on the angle. Okay. Points W, X, and Z are all on angle 3. We can have points that are on the interior. Angle U is on the interior of angle 3. Angle Y, or I'm sorry, point Y would be on the exterior of angle 3. Okay, it's on angle 4, but it's the exterior outside of angle 3. Okay. What's another way for number 2? What's another way we could name angle 3? Yep.
Angle ZXW.
Okay, we could name it angle ZXW. Could I use just the vertex X?
No.
I heard yes, I heard no.
No, because it's not the only angle on the...
Right. Okay. I can't call it angle X because if I say angle X, looking at the picture, I don't have any idea which angle we're referring to. Because angle 3 has the vertex of X, angle 4 has the vertex angle of X, and then the great big angle, WXY, has the vertex of X. So that's why we cannot use X. Jordan, you need to sit up or go to the focus room, please. Ian, you too. Angle 4, how can I name angle 4? X.
ZXY.
Angle ZXY. Again, we could switch those letters around. The X has to stay in the middle. Okay. So sometimes you can get by just using the vertex or the angle number. Other times you have to use 3 letters to name that angle. Again, you have to have that angle symbol in front. If you don't have the angle symbol, then you are naming a plane. Okay. 3 letters together name a plane if there's not another symbol with it. Then these 4 angles, which again should not be anything new to you. You see boxes in your interactive notebook with those 4 angles. Okay, so draw in an example and also include this information about their size. So again, these 4 angle classifications you should be familiar with. That acute angle between 0 and 90, obtuse between 90 and 180. Straight angle, again, is something you just have to get used to that terminology because when we look at the picture, we think of a line. A line, though, in this straight line, we also see 2 rays, which we've talked about before. They are opposite rays. And so because we have 2 opposite rays that share the same vertex, it fits the definition of an angle. And so lots of times if they're referring to the angle, you will see, like we see in this picture, the red arc all the way across, indicating that we're looking at an angle rather than that line itself. So a straight line is 180 degrees. The right angle. Important thing with right angles is that in geometry we can never make any assumptions. So we either need to be told verbally that it's a right angle, or we need to see that box in the corner that tells us it's a right angle. Otherwise we can't say, well, it looks like a right angle, it must be. So we need to be careful looking for that marking on the angle. So then if you fold that page back up in your book, we see examples. So they want us to name the angle, tell whether its measure is less than 90, greater than 90, equal to 90, or 180, and then to classify it, so using that word. So I'll give you time to quick run through that. So number one, what did you do to name angle 1? I'd like to share. Caleb? Angle X, Y, Z. Anybody use anything different to name the angle? Everyone wrote down X, Y, Z?
I just did Y.
Okay, just did the vertex Y, is that okay?
Yeah.
Yes, because this is the only angle, so we could just use Y. Or with this first one with the 3 letters, we could have switched the X and the Z around. Y has to stay in the middle. So what's the measure? Less than, greater than, or equal to 90, or equal to 180? It's equal to 180 because it's a line or a straight angle. So classify the angle is straight. Number 2, what are we going to do to name angle 2? What did you use, Bailey?
Angle FPY.
Very good. Angle FPY. We can just trace the angle so that P has to be in the middle, or we could switch it YPF. And again, we could also just use the vertex P because that's the only angle in the picture. So what do we know it's about its measure? It's less than 90, which means the classification is acute. Number 3, how am I going to name number 3? What'd you do, Ian?
Angle CTL.
Angle CTL.
And then 90 degrees.
Okay.
And then equal.
It's equal to 90, so it's a right angle. Thank you, Ian. And then the last one, Cadence. What did we do for the last one? Angle SUN. Okay. So what's the measure? Greater than 90. So it's classified as a obtuse. So again, pretty much a review over angles. The next thing we're going to look at is the angle addition postulate. This angle addition postulate is doing the same type of thing as what we saw with the segment addition postulate. Okay. But instead of working with segments, we're working with angles. Okay, the idea is the same. It says if K is in the interior of angle HIJ. So I've got this big angle HIJ, and I've got this point K that is inside, in the interior. Okay. Then I know that the measure of angle HIK, and KIJ is going to equal the measure of HIJ, which is the great big one. Okay, so just like with the segment addition postulate, we have two small parts that combine to make the great big part. Okay. So if you think of this as maybe being a big slice of pizza or a big slice of pie, okay, we're just dividing it into two parts. The two parts would be the same size as the big piece that we started with before it was divided. Okay, so that's our angle addition postulate. Two parts equal to the whole. So you have to look at your picture carefully so that you set up your equation correctly. So we've got some examples. So it says the measure of angle AOC is 70. So angle AOC is the great big angle. So when I mark that in my picture, I usually show the great big angle and put that 70 on the outside. I have angle AOB, which is half of 2x plus 20. What is half of 2x plus 20? X plus 10. So angle AOB is x plus 10. And angle BOC is x. So I need to solve for x and then find those two small angles. So what's my equation going to be? What do I have to do?
X plus 10 equals 7.
Okay. So I have to add the two pieces together. So I have an x and I have x plus 10. Parentheses aren't necessary. I just use it to show that I'm adding the two pieces together equal to the whole.
So 2x equals 60.
So I'm going to combine like terms. Some of you are trying to do a lot of stuff in your head and are making silly algebra mistakes on the quiz. Okay, so make sure you watch what you're doing. So 2x is equal to 60 because I subtract 10. Okay, some of you are adding 10. Okay, if you need to physically write that down, you're subtracting 10 from both sides. I'm dividing by 2. Okay, I am not going to write all of that down. I say it, but I'm not going to write it down. Okay, because this is geometry class, not algebra class. Okay, but if you need to do that, you can write that so you're not making mistakes. So we found x equal to 30. Then I need to find angle BOC. Angle BOC is x, so it is 30. Angle AOB is x plus 10, so 30 plus 10 is 40. And then again, you should check your work. 30 plus 40 does equal 70. Take that time to check. Again, on yesterday's quiz, some of you would have known you made a silly mistake if you were checking your work. So you need to get into that habit of checking your work. Okay? So same thought process as what we had with the segment addition postulate.